Okay guys, so I'm gonna go slow because I messed up. This is the second time making the video, so I want to just be very deliberate. I didn't mess up till C, which was also devastating because I was almost done with the video. So let R be the region in the first quadrant bounded by the x-axis, the graphs of natural log of y equals natural log of x, and y equals 5 minus x. So this one here is y equals natural log of x. This one here is y equals 5 minus x. So as shown in the figure above, find the area of R. So I've got to use top minus bottom and the integral of top minus bottom. And what you'll notice, guys, is that I don't have my transparency. But what you'll notice is that the top minus bottom actually changes. So from 1 all the way up to this intersection point, top is the natural log, and then the bottom is the x-axis. So the bottom is 0. So top is natural log, bottom is 0. Anytime that an axis is like a top, bottom, left, or right, that's 0. So an axis is always 0. But then after this point of intersection, the top function becomes 5 minus x, and the bottom becomes 0. So we've got to split up this into actually two integrals here. So, yeah, so this will be, so top, bottom, and we've got to find this point right there. So I will use the calculator. I already have these graphed from yesterday. I graphed them. I'm trying to find that intersection point, second, trace, intersect. Okay, so I will call these points A and B. Right now, I just need A. If I need B later, then I will plug A into one of those, and then that will give me the y coordinate. But right now, all I need is the x coordinate A. So I'll write that down. So A equals 3.693414, and I will store that. So I hit X, and then I store it. I'll store it as A. And so I'm going to do the integral from 1 to A of, okay, so top minus bottom is natural log of x minus 0 plus the integral from A to, this point here is, that point there is 5. A to 5, and then 5 minus x minus 0 dx. And then just plug that into the calculator, and yeah, just do math 9. And this is a guide video, guys, so try to do as much of this without me as you can. So math 9. 1 to A, natural log of x plus A to 5 minus x. 2.986. Okay, so that is the area of this region. Now for part B, region R is the base of a solid. All right, so this region R that we just found the area of is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Write, but do not evaluate an expression, involving one or more integrals that gives the volume of the solid. So we're going to have these squares coming up out So these squares are perpendicular to the plane. They're coming up like out of the shape. And we're going to have one formula for the areas of the squares to the left of A, and then we'll have another formula for the area of the squares to the right of A, because we got to use top minus bottom for the base of the squares. So this is for part B. So I'll go like this. Let me think. All right, let me say it like this. So the volume is going to be, you don't have to write exactly everything I do, guys. But it's going to be the integral from 1 to A. Now I'm going to have two different like areas, so I'll be like area 1 of x dx plus the integral from A to 5, area 2 of x dx. Area 1. Guys, the area of a square is base squared because the base and height are the same. So top minus bottom for this square is natural log of x. And then area 2 is again base squared, but top minus bottom here is 5 minus x. All right, so we do this, then we've got the volume is the integral from 1 to A, natural log of x squared dx, plus the integral from A to 5 minus x squared dx. Okay, right there. All right, now for C, this is where I messed up last time. All right, and you should do as much of this again. You should do as much of this on your own as you can. This is a guide video. All right, part C. The horizontal line, y equals k, divides R into two regions of equal area. Write, but do not solve, an equation involving one or more integrals whose solution gives the value of k. Oh, guys, I forgot to mention before. Write, but do not evaluate. Write, but do not solve. So in those cases, and I've said it in a past video that you may or may not have watched, you've got to be super cautious when you hear these words not to go too far. Solving would be just an enormous waste of time because you don't have to. Like right here, that's the answer. You didn't have to keep going. So again, we're just going to write but not solve. Oh, excuse me. So what I'm going to do, and again, I don't have my transparency, but I want to like place a horizontal line somewhere where it looks like it splits the region's area in half. And I don't know, I'll just estimate like, or actually, let me do it down here. I drew a separate picture last time. So, all right, I'll go like, all right, so what was it? It was like this, and then a line. Okay, and then we've got this blue area. I'm trying to cut it in half. I'm trying to find a horizontal line so it looks like we've got the same area above and below it. I don't know, maybe there. No, that's not great, but it gives you an idea. Y equals K. And guys, I am supposing that this horizontal line makes it so that this area, this blue area below it and this blue area above it are equal. And keep in mind, we already figured out what the entire blue area was. It's 2.986. So what I'm going to do is I'm going to find an integral that represents this bottom area, and then I'm going to set that equal to half of that. Another way you could do, which I actually did, which I was going for in my last attempt at this video, was, excuse me, I'm sorry guys. You could find an integral that represents this bottom area, and then you could set it equal to an integral that represents the top area. You could do that. Now guys, here's the thing. The bottom area, since this is a horizontal line, that's cutting through it, if I were to use top minus bottom to represent this area, it would be a huge pain because top minus bottom is different here than it is here, and then it's different again there. So the top function changes three different top functions for this area here. First, its natural log is the top. Then y equals k is the top. Then the line is the top. Don't use top minus bottom there. It is a mess. So we want to instead use right minus left. So we're going to use the integral from y equals a to b, right minus left dy. So we need everything in terms of y, which means to solve for x. So the right function is x equals y minus 5. This left function is x equals e to the y. Guys, if either of those don't make sense to you, pause the video and think about it. I'll talk about this one. So to solve here, I just put a base of e on both sides. So I had e to the y equals e to the natural log of x. E and natural log cancel. Okay, so the integral. All right, the lowest y value, so I'm just looking at this, I'm ignoring this top half. All right, I'm just doing the area of that bottom half. So the lowest y value is 0. The highest y value is k. And then in here, I've got to do right minus left. So the right function is y minus 5, minus the left function is e to the y, dy. So right here gives the area of that bottom half. We know the entire area is this. So I'm going to go 2.986 divided by 2. And I could just leave it like that. Or I could actually get this decimal if you want. But yeah, right there is fine. Let me just show you what I did. I mean, I messed it up, but this is what I did before, and this is actually what I meant to do. This also would be an option. Okay, just in case anyone did this. I actually found this y coordinate. I plugged a, which I had stored, into, I think, this one. And I got that b was this, and I wrote it down for my reader. So I had that this point was ab. And then I did the integral from 0 to k, right minus left. And then that's going to be equal to the integral from k to b, right minus left. So I just set this bottom area equal to that top area is what I did. That would also work. But this one is much cleaner.